It's a special meetup in cooperation with Craft.
My job is basically as a technical agile coach, but I have been doing approval testing for many years, and I think it's a really great technique that more people should know about. So I'm going to talk about that this evening. And my assertion is that this is a great approach for getting readable, maintainable tests, even if you have legacy code. And because this is a situation that I meet a lot when I'm out consulting. I meet teams that have a large, complicated code base. They don't have very many unit tests or tests at all, but the code is really valuable. It works, it's earning money, and they need to work with it and maintain it. The typical agile testing advice is like the test pyramid. This is Martin Fowler's picture of it, that you want to have lots of really fast, cheap unit tests, some service tests, which are kind of medium fast and medium expensive, and a few tests that go full stack through the UI that are very slow and expensive. And this is the standard advice. And it's good advice in many situations, but if you've got this large, complicated code base that doesn't have any tests, then it might not be so easy to reach this situation. So typical challenges in that big legacy code base is that it doesn't have unit tests and it doesn't have any suitable units for making those unit tests. And so you need to refactor it to make the units, which means that you risk breaking it because you have no tests to catch the problems. So this is a typical difficult situation. The other thing I see is that people do have unit tests, but they're using so many mocks that they are really difficult to maintain, and they very seldom find any bugs, and they make refactoring harder. So this is almost worse than not having any tests, honestly. So I can see where people get to this because they're like, oh, you have to have unit tests. They start writing loads of unit tests, but they write them badly. And the situation could be worse. So this is not what you want. So end-to-end tests, though, a lot of people then would like to have end-to-end tests. They are slow and expensive, as we mentioned, but they do find important issues often because they're written from the user perspective. Often these end-to-end tests actually do find things that users care about. So a lot of teams that have legacy code find that their end-to-end tests are valuable, but they're just a bit too slow and expensive for it really to be practical to lean on them while refactoring and improving your situation. So these are the kind of problems I see when I'm meeting teams. And this is where I usually okay, let me introduce you to approval testing. I think this could help. So this is the alternative that I would like to suggest to this, all these problems is approval testing. And it's not just the approval testing, that's just one kind of part of this. I think there's 3 stages here. First, you need to try and isolate units in your big legacy code base that are probably larger than typical unit test units. But you need to isolate pieces of it. Then you need to cover them with approval tests. So it's like you've got your big legacy code dresser, pull out a drawer, isolate that bit, go through everything in it, take out all the socks. That's like cover it with approval tests, find out what's in there, what does it do, what are the important behaviors. And then when you've got this piece covered with approval tests, then you can refactor it. You can organize all your socks and make it really easy to add new socks. New features, That's the point of refactoring though, isn't it? It's to make it easy to add new features. So I think there are these 3 parts to the strategy to get this legacy code under control. So I wanted to talk about that first part, and I have a demo, just a minute. This is an application that I didn't write. It's on my GitHub, so if you want to go and get it later, it's called RESTful Booker. And here I'm just showing you that I can get the code, and I put it in my IDE, and I run npm install, and then I run npm start. And it starts running this demo application, and I can go to it on localhost. And you can see here, again, I didn't write this. This is Mark Winteringham, who wrote this as a demo application for testers to learn about API testing. And I thought, well, this is a kind of example of a piece of code that I could showcase how to write approval tests for it. So I didn't write this code, but I did modify it so that it would be suitable for approval testing. So that's what I'm just going to show you. So the thing has documentation. It's a REST API for creating bookings at a fictional hotel, and it has lots of bugs in it, so it's really nice for testers. Here we can see the documentation. It's got really good documentation as well. On the left-hand side, you can see all the REST endpoints that it's got, and I just wanted to draw your attention to a couple of them. So it's got the health check endpoint and some other stuff. I'm going to show you the health check a bit more in a moment. There we are, yes. So the documentation here, it says, look, if you call this on curl, then it should produce that response there. So I'm just going to show you that does actually work. So if I copy that curl command, it's going to access that endpoint. I can just show you that it does work. And then I get back a response that says 201 created, and that's it. So that's just to say, look, I'm up and running. A more interesting endpoint is get booking. So that one there is where you ask it for a particular hotel booking by number. And again, you can run it on the command line, and it comes back with 200, OK, and then you get a bunch of JSON for the booking. So, I mean, it's a REST microservice thing. OK, so that's what it does. Now I want to test this with approval testing, and it's already got a command line interface, which is great. But in addition to that, I need it to also be isolated, that I can isolate the data. I've got to control the data. So I had to make two changes to it. I had to ability to populate the database with known data, and then ability to dump the contents of the database to a file. So, and then I also, after that, also needed to get it into a test rig. So I'll skip over the part where I made those two modifications to be able to affect the data in the database and gather the data from the database. And then I'm going to write my test rig. I know this is a bit small. This is a Python script. And I'm just starting out with a hello world Python script. And then I'm just showing you, if I run this, it does in fact say hello world. I'm getting there. I'm sure you've all seen Python before. Right, but what I actually want this to do is start the microservice. And then I want to do one request response against an endpoint. And then I want to stop the server. And the other little thing I want to do is I want to be able to run lots and lots of these in parallel. So I'm going to make sure that each time I run it, it finds a unique port to run it on. And it's going to, each instance is going to have its own copy of the database. So that was a little bit of code I had to write in order to execute this thing. And I'll skip the rest of it where I actually write the rest of the test rig. Because this is upfront work that I needed to do to get my application to be testable. And I kind of think you have to do that. And you need a developer to do that, probably. But once you've got that, then you can start approval testing it. So let me just go back to my slides for a minute. So I'm hoping that my slides are here. Yes? Okay, so that was the demo of, that was what I need to do, isolate a unit of behavior. I'm controlling the database, I'm controlling the service when it starts. I can run lots of these in parallel with different databases and different requests. And what it's going to do at the end is just going to write the database to a file, and any response that it got from the microservice also to a file. So that's my test rig. That's the isolating part. The next part is then cover this with approval tests. And basically, then a bit of theory here about what I just did. Test bigger units is the kind of thing with approval testing. That whole microservice that I just isolated is a lot bigger than what you would isolate for a unit test, but it's not the whole system. I'm imagining there's other microservices that do other stuff around this system. And it's something that I can start and stop with a little bit of data and run it quite quickly. And it's a behavior that actually makes sense for the whole application, not just a kind of internal implementation detail. So test bigger units, I think. So a user would understand this piece. I don't want to mock if I can help it. This service might talk to other services. I might need to mock them. Ideally, I would actually use a record replay mock, like a capture replay mock, that I could run against the real one to update it. That's a detail which I wasn't going to go into in today's talk. But anyway, I also want to make sure that I can run it with a very small amount of data so that I can run it quickly. And I also want to be able to run lots of these in parallel so that even if my test takes a few seconds, I can still run a lot of them. These days, you've got a lot of CPU power on your desktop. You can run stuff in parallel. So that's what I want. And the other thing is, I mentioned, of course, you have to collaborate, developers and testers, for this to work. So I think to write that test rig, I think you need some developers. You need to work on making the architecture testable. But in order to know which behaviors are interesting and which tests to write, you need some testers. So I think this whole approval testing thing works best when you get a good collaboration between testers and developers, basically. Okay, then there's the other part. So covering it with approval tests. Let's do the demo. Let's see if I can get this demo part. Yes. Okay, so. Okay, so in a moment, it's going to show you what it looks like in the test. This is, okay, so the window at the front there, that's a tool called Teszt. And it's got a little GUI showing you a test explorer. So I've got one test case. It's called ping, and it's highlighted in blue. And on the right-hand side is the details of that test case. And you can see perhaps there are two sections. One's called data files, and one's called approved files. So let's look at the data files. So the rest command.txt, that is, and the database.json. That defines what this test is. So the db.json, that's what I'm going to put in the database. So this is a booking thing, so there's a bunch of bookings there that I'm going to put in the database at the start. And then the REST command, that's what I'm going to ask the microservice to do. And I was going to start with that ping endpoint that I showed you first that just says, I'm alive. So this is quite a straightforward test, hopefully. And then you've got all these approved files. And those are what the test creates while it runs and checks against the approved version of those files. I've got quite a few of those. One of them is the response text that you get back. It says created. The status code, I think, was 201. Anyway, I can run it and it passes. Come on, I paused it. There it was, it passed. So that's not very interesting. Let me show you creating a more interesting test. So I'm going to create the one for the booking, get booking. And for this one, I'm going to need some data files. So in particular, that REST command. And for this one, it's a different endpoint. I need to get booking number 1. And I think I need a slash beforehand as well. Yeah, booking number 1. And then I'm going to use the same database in all the tests, actually, the same starting database. So that's why it says that it's inherited from the parent. So I've just defined the database in one place, and then all the tests inherit it. So I don't know if you noticed, there weren't any approved files there, because I just created this test. I haven't approved anything yet. So the first time I run it, then, you see it open this new window to run the test. It fails, because it doesn't know what to compare stuff against. So on the right there, it says new files, and then it's found, 5 files or something that were created when it ran the test. And now I have to go through these and work out, is this what I want? Do I approve these? So I'm going to just have a look at them. If I just rearrange the windows. So I've got these 5 files, and let's look at, this is the headers, the HTTP headers. Now, I might not really care about these, but it's fairly easy to collect them and put them in a file, so I might as well. The next file is a bit more interesting, though. This is actually the JSON that I got back when from the REST endpoint. It's, this is my new booking, booking number 1, Mary Brown. So that's good to check that I got the right booking and it had the right data in it, and it didn't crash. So that's good. The next file is just the HTTP status code. We got back a 200, everything was fine. The next 2 files are from the test rig, standard error and standard out. Standard error is empty, and standard out. This is, as I said, the test rig. When it's running, it just says, look, I'm starting the server, and I'm running this REST command, and then I'm stopping the server. And that's all. So if anything goes wrong and the test rig breaks, I'd get something in standard error, or maybe it wouldn't write something here. So this is more for debugging than actually checking my application is working. So yeah, so that looks great. So I can just select all those and tell it to, I approve these files. So now it goes green. I now have something to compare against. So going back here, I now have approved files. And they're all there. And I store those in version control. And I can run the test again, and it's green because everything matches the approved files. And I can run all my tests, and they all pass. So this is great. I have regression tests. Of course, there's a bunch more endpoints that I need to write tests for as well. So I'm just going to skip that part. It's fairly similar. You have to write the little files for the REST commands to do. And I don't know if you can see, but it's running 2 tests at a time in parallel here. If you can kind of spot that, the running, I've just paused it while it's running. So now I've got like 8 tests, and they're all working. And each test takes like a second or something. But because I can run them in parallel, it doesn't take very long. So I wanted to show you one where I created a new booking. It needs to post some data. That's the data I'm posting. So this one needed another additional definition file. And there is my new booking that comes back, booking ID number 11. And I have to check then that in the final database at the end that booking number 11 is there. So I could check that it did create it. It's in the database. So I think hopefully you can see that I had to do quite a lot of investment in my test rig and my testability. But now creating more approval tests is, for the whole functionality, really was quite straightforward. Anyway, so back to the presentation. So that was, now I'm going to tell you what I showed you. So yeah, so each test case is going to submit a particular kind of request and particular database contents to start with, run the test rig, and then check that the response and the final database were exactly the same as before, as the things I approved earlier. And then I didn't show you a test failing, but if it had failed, you would have looked at a diff like this, a diff between the actual outputs and the approved outputs that you were expecting. So this is a completely different application called the Supermarket Receipt Refactoring Kata, which is very accessible. You can get this off my GitHub and have a go at it yourself. And it's, you can see there's a bug here. I hope you can see there's a bug here. So in the approved output, we were getting a discount of 99 cents on toothbrushes. And in the actual output, we're not getting a discount. So there's a bug. So clearly we need to go and fix it. But you know, if this was actually what we wanted, maybe we'd stopped doing discounts. We could just approve the new version. And that would just be a click of the mouse. Approve this new version, and then we'd have updated our test. So this is the thing with readable, maintainable tests. Tests always give you this nice diff to help you understand what's going on and make it easy to maintain tests just using a kind of a diff merge tool. And yeah, there's a bit more to it, but basically, I think it's much easier than messing with assertions. Yeah, so talking of assertions, the classic way to write a test or an automated test or a unit test is arrange, act, assert. I'm kind of assuming you've seen this. You know, you arrange the thing you're trying to test, then you exercise it, and then you make claims about what happened. So with an approval test, you still need the arrange and the act, actually. But the assert turns into a diff, diffing it against the approved outputs. And for that, you use this diff merge tool. So in the example I just showed you, though, the arrange step was basically finding the data that I wanted to set up my application with. The act step was running my test rig, and then the diff against the approved files. So this is, it's kind of like what you know, but there's this extra part with the approved files. So anyway, I'm kind of giving you a basic introduction to this, I hope. The basic strategy is isolate units of behavior that are bigger than classic unit tests, cover them with approval tests, and then you can do your refactoring. So we want to go through all the important behaviors, and for this it helps to have testers and people who understand what the important behaviors of your application are, and you want to try and make that output that you're then going to diff readable to somebody who isn't a coder. It should be, I mean, this was JSON, it's kind of readable. But if you know the domain, hopefully you'd be able to say, oh yeah, that's a booking, it's got all the right fields to be a booking. I understand that. And then I wanted to also point out that the basic thing is that once you've got your test rig, you should be able to create lots of tests using the same test rig, data-driven testing. And then when a test fails, you've got lots of similar failures that you can apply the same fix to. So the maintenance is less costly than updating a lot of assertions, in my experience. Yeah, and then you can do your refactoring. If stuff fails, you get these nice readable diffs that help you to diagnose what you've done wrong. Okay, so if you want to learn more about this, the tool I just demoed was called Teszt, and that's the one that I'm one of the maintainers of. But I wanted to also mention approvals, which is easier to get started with. If you just want to try it out for yourself, it's much closer to unit testing. It's quite easy to get going with. It's got good documentation, mostly. And yeah, so have a look at those. And I've got loads of things on GitHub that would let you try out approvals, honestly. Yeah, so that was my talk. Thank you for having me.
What I was, when we were chatting earlier, I was saying this is probably my 6th time or maybe 7th time here in Budapest for CraftConf. I love the conference, I love the people here, I love the food, I love the city. So it's my pleasure, deep pleasure, to be back here in Budapest.
For being the host.
So thank you.
It's a great place.
So yeah, this is going to be very, very a different talk, but also very compatible with what Emily said. So I think you'll see that. So yeah, so I want to talk a little bit about software delivery at scale. So just a sense of my background. So right now I'm the chief architect of eBay. I also used to work at eBay starting in 2004, and I worked there for 7 years. I was working at other places for 10 years, at Google, at Stitch Fix, and at WeWork, and then now I'm back at eBay for the last 2 years. And some of the stories and ideas that I'll tell will be from all of these places. So I want to talk today about software delivery, but I want to put software delivery in context. When I say software delivery, what do I mean? So this is my words, but I think that if we think about the life cycle of product development, we start with an idea, and we hopefully end up with customer value and business value at the end, right? Start with an idea, we get value. And so where does software delivery fall in here? Well, in my mind, there are 4 sort of phases. One is planning. How does an idea become a project that we work on? Software development is how does a project that we decide to work on become committed code? Software delivery is how does a code become a feature? And then there's another phase, I think, that I will call post-release iteration, where it's in production and we're learning with analytics and experimentation, and we're iterating on the feature. And so that's how the feature becomes value. Anyway, so I'm not going to talk about the other 3 phases, but I just want to talk today about the software delivery phase. So it's hard to talk, in 2022, if one talks about software delivery, it's important to mention the Accelerate book. So who's familiar with this book, Accelerate? Good. Oh, great. So I can introduce it to many of you. This is wonderful. Thank you. The Accelerate book was written in 2018, and it comes out of the state of DevOps surveys. So starting in 2014, and now for 8 years, they've been surveying software developers all around the world. And it's actually the largest and longest running software research study ever in the history of software. And what's different about this versus other things we think we know about software is that there's a lot of rigorous science behind the state of DevOps surveys, and that is reflected in the Accelerate book. So Dr. Nicole Forsgren, who's a data scientist, collected for many years, all these survey responses, and she summarizes the things that she and learned in this Accelerate book. So I recommend that you take a look at it. Well, so here's some of the things that they learned. So different organizations cluster together. So there are low-performing organizations that are bad at delivering software. They're bad at how fast they deliver software, and they're also bad at the quality of the software. But and there are medium performers that are sort of okay at the speed of of delivering software and the quality. And there are high performers that are better at it, and then there are elite performers that are very, very good. So the first thing I want you to notice is that there are different clusters. Every year, there's a low-performing group that is poor on quality and poor on speed. There's an elite performing group that is excellent on quality and excellent on speed. But the other thing I want you to notice is every year, the best are getting better. Every year. So, back in 2018, they identified a very small percentage of organizations, 7%, that they called elite. And in 2019, that was 20% of organizations. And now in 2021, which is the last time they did the survey, it's 26%. So if as an organization, we are not getting better every year, we're actually falling behind. Does it make sense what I'm saying? Because the industry is getting better, and so if we stay the same, we actually fall behind. It's pretty interesting. Okay, so the other thing that the other important part of the science, and this is going to be very hard to read, so I'll just tell you in words, is that the key contribution that Dr. Forsgren has made to our whole industry is she's figured out that there are 4 metrics that measure software delivery performance. And those metrics are scientifically connected to good business outcomes, which I'll tell you in a moment. So this is what we would call an eye chart in English. So it's very hard to read. But I'll tell you quickly the metrics, and then I'll tell you more about them. So one is deployment frequency. How often are we delivering new software to production? Lead time for change. What's the time that when a developer commits her code to when it shows up in production? How long does that take, that lead time? Time to restore service. So when we have some kind of incident or issue, how long does it take us to recover from it and bring it back to a good level? And then change failure rate. What's the percentage of time that we we deploy new software and we have to roll it back or hotfix it or something like that? And again, there's a big difference between the low performers, the medium performers, et cetera. So the low performers, all of these things are measured in months. They deploy maybe once every several months. Between the time somebody commits code and it shows up on production, that's measured in months. When they have something bad happen, sometimes it takes them months to recover. So that's low performers. Medium performers, those things are measured in weeks. High performers, those things are measured in days. And elite performers, those things are measured in hours. Hours. So the very best of the and again, those elite performers are growing. It's now 26% of the people that are responding to this survey are in that elite category. So, the Amazons, the Googles, the Netflixes of the world, they are deploying many times a day. The lead time between when somebody commits her code and it shows up on the site is maybe 1 hour, 2 hours, 3 hours. And when they have an issue, they can repair that issue in production also in an hour or several hours. So let's try to figure out how this happens, because this is pretty interesting, right? This is pretty powerful. Okay. The other thing is that these engineering outcomes that I was talking about, the lead time, the deployment frequency, et cetera, they're also, the people that are really good at that, the elite performers, actually spend more time doing real work and less time doing maintenance and repairing things. So the elite performers spend 44% more time, the developers in those companies, 44% more time building new features than they do on maintenance and other things. And also, oh, by the way, the high performers and the elite performers are 2.5 times more likely to be profitable, to have larger market share, to have better productivity of their companies. So like this stuff is really, really important. So now let's talk about what's involved in this. I'm going to talk about not all of the ideas, but a few of the ideas that hopefully will be interesting to you. So first I'm going to talk about the technical practices that are involved here, mostly about testing and quality. Next I'm going to talk about some process things, and finally I'll talk about some cultural things. And by the way, this is very casual. Feel free to interrupt me anytime with a question. I would be very happy to answer it anytime, really. OK, so let's start with the technical practices. So I've been in software for a long time. Let's see, 34 years. And I hear this a lot. I hear, we don't have time to do it right. And maybe you guys, as testers, maybe you've heard that too. Here's my response. Do we have time to do it twice? Because that is the trade-off, right? So if we don't do it right the first time, we're going to have to come around and do it, right the second time. So this is, if you ever get into this situation, as I am often in this situation, you can respond with this way. Okay, and interestingly, the more constrained we are in terms of time and resources, so the more limited we are, almost the more important it is to get it done the first time. Why? Why is that true? It's because we don't have time to go back and do it the second time, right? Like if we're in a startup, we're in something, we have very few number of people, we're very, we have lots to do and not a lot of people to do it. If we can just do one thing and do it well, and then the next thing well, and the next thing well, and the next thing well, we'll be able to keep moving forward. And if we do something that's not very good and we have to go back and fix it, like we're never going to move to the next thing, and the next thing, and the next thing. Does that make sense? It's very counterintuitive, but I hope it makes sense. OK, cool. So hopefully this is something that will be exciting and interesting to you all. One of the major ideas in the State of DevOps research and in the Accelerate book is this idea of continuous testing, right? So a lot of the things that Emily talked about, would be part of this. And I don't think I need to convince you of this, but maybe if you need to convince other people, tests help us to go faster. The effort that we spend building tests help us to go faster. Why? It's because if I want to run fast, I run a lot faster on solid ground than I do on, sand, right? Tests are the solid ground. Tests allow us to keep moving forward. And tests are also the safety net, as Emily was suggesting. Tests are the safety net that catch us when we make a mistake, when we introduce a bug where the discount doesn't work, something like that, right? The tests are the safety net that help us to catch ourselves. When we add tests, we make better code. Why? Because it gives us the confidence to maybe change the code in a very radical way to make the code easier to modify. It gives us the courage to do those major refactors. And the tests will be that safety net and will catch us when we introduce a problem. And then tests help make better systems, right? So they help us to catch bugs earlier in the life cycle, and then they help us to fail faster and to get better faster. So this picture here is actually in Budapest from several years ago. Maybe you will recognize this, train. It's one of the kinds of trains that go up a very steep hill, and in the center is a it's called a rack rail in English, and you know the sound. It goes chunk, 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 right? Why do I show that picture? It's because every time we add a test, chunk, we move one step forward and we can never slip back. Does it make sense? Another test, chunk, moves us one step higher up the mountain. And this is why this design is how a train could move up a very, very steep hill here in Budapest, in the Alps, all over. Does it make sense? Chunk, 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 chunk. OK. All right. The other thing, which I don't need to convince you of, but maybe you will need to convince some of your colleagues, is testing. A good testing suite will improve the productivity of the developers. Why? Because, so Microsoft did a study a long time ago, but I think it's still probably true, about what do developers spend their time on. And it's not what you think. It's not even what the developers think. The developers think, you know what, I spend 80% of my time building new code. Wrong. Developers spend about 5% of their time writing new code. They spend about 20% of their time modifying existing code. And they spend about 75% of their time simply reading existing code so that they can add new code or modify the existing code. Does it make sense? So if we have an effective suite of tests, what we have done for the developers is we have made it a lot easier to read the code. Why? Because the tests are executable documentation about how the system should work. And then obviously it makes it easier to modify the existing code because, of course, tests are that safety net, tests are that solid ground that will keep us going. It actually helps writing new code as well if we write tests along the way when we're writing new code. But you know, I'm happy with improving the developer productivity of 95% of their work. Does this make sense? Yeah. OK. One of the places that I worked from 2016 to 2018 was a US company called Stitch Fix. The details aren't important. I'm happy to tell you about it. But one of the things that I loved is when I joined the team as the leader of engineering, they had already had a very strong culture of test-driven development. And what I got to see during those 2 years there was that by building the tests along the way between developers, between testers, they basically didn't have a bug tracking system. I mean, we did have a bug tracking system, but there were very few bugs at any given moment. Why? Because the tests that they had built over time were catching the new issues before they ever reached the customers. Does it make sense what I'm saying? Like they had built up this suite of tests, and you know, the developers would introduce bugs all the time. I mean, they weren't magical people. They were just like anybody else, just as fallible as anybody else. But the wonderful thing was that we would find the bugs and fix them before they ever saw the customer. And so rather than other places like eBay where I work now, where we have a list of thousands upon thousands upon thousands of production bugs, this was something where we were close to zero all the time. And by being close to zero all the time, it meant that when some issue would happen, we could just jump right on it and fix it right away, right? Because there was only one bug or 2 bugs or 10 bugs, something like that. We could jump on them and fix them as opposed to looking at this backlog of thousands and thousands of bugs and kind of giving up, if that makes sense. Anyway, so this was an example where I really learned a lot about the power of testing. OK, so this is a little bit of analogous or complementary to what Emily was saying. So, and we didn't coordinate with each other, but I think we're going to be agreeing very strongly. So when you have a situation where we don't have a lot of good tests and we want to introduce a lot of tests, I agree 100% with Emily's idea that rather than starting with adding a bunch of unit tests, let's start with adding, I call them functional tests, but imagine approval tests or acceptance tests at a higher level, and start with that. Again, why? Because probably it's not the thing you want to test isn't very testable. And so writing functional tests that are on the outside and test end-to-end the capabilities or the features of the component or the system is a great way to start. And then what I've also found is we start with a few tests, and then anytime we have a build that violates a test, we say stop, and we fix the build or we fix the test. And then, just like this rack rail, just like this train, chunk, 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 we opportunistically add new tests. So every time we find a bug, we add a test that will reproduce the bug, and that test verifies the fix that we put in works. Again, super simple, super obvious, but like if we keep doing this, every time we find a bug, we make the system better. Chunk. And for every new feature that we add tests for that feature. So this is a slowly but surely a way of taking a system that has no tests and adding tests exactly where you need them, right? Where do you need them? You need them in new functionality that's never been tested before, and you need them in places that broke, right? So this is the way that I found, to add testing to areas that don't have it. Okay. So the other technical practice I want to talk about is deployment automation. So at eBay, one of the things that we have introduced since I've been back for the last 2 years is a lot more emphasis on continuous delivery pipelines, building and maintaining pipelines that allow us to automatically build and test and deploy the software. And for most of eBay, we're in that medium performer category, so everything is measured in weeks. But for some of the teams, they are actually doing things measured in hours. And we'll talk about this a little bit later. But if you can release software, every couple of hours, it allows the individual units of change to be much smaller. And we'll talk about this later. Those individual units will be much less risky and much easier to test and easier to roll back. The other thing that's related here is we've spent a lot of effort on my team building a template for deployment pipelines that allow all the individual teams to assemble their own pipeline out of individual components. And just to give you a sense of scale or whatever, eBay has about 4,000 engineers, worldwide, and we have probably about 4,500 applications and services in production right now. Our goal as the platform team is to make sure that every one of those 4,500 applications and services has a really solid deployment pipeline that allow all their teams to be more productive. One thing that we introduced relatively recently, or over the last 2 years, which is pretty standard in the industry, but it's new to us, is something called canary deployments. And so the idea is we want to automatically roll out new software to production. And so we want to do it in stages. So maybe we want to roll out to 1,000 instances, and so maybe we start with 1%. So we start with 10 instances, and then we maybe move to 100 instances, and then 300 and 600 and 900, something like that. So we go slowly, and then we go more quickly when we gain confidence. And the thing about the idea of the canary deployment, you probably are familiar with it, is that the system watches, we have monitoring to watch the metrics of the system. And so if, as we're rolling out, we see that the new code has more errors, or it's slower, or it has any of the other issues that you could have, if it's bad, then we automatically roll it back. And if it's okay, then we keep rolling it forward, rolling it forward, rolling it forward. And the thing that's wonderful about this for the developers, well, for everybody, testers, developers, is that this is all automatic. So conceptually, they press the button to say, deploy this now, or more precisely, they simply commit their code, the pipeline runs, dunk, 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 and then it starts to roll out, and if it fails, it automatically rolls it back, and then we can take the time to figure out what went wrong. And the goal here, obviously, is to make deployments just routine and boring, right? In a lot of teams still at eBay, where they're deploying, once a month, twice a month, something like that, deployments are a really big deal, and they plan for it, and it's like really hard. And we talk about it like, okay, is everybody ready? And the goal of all this automation is to have it be just simple. It's not a big deal, right? The machines roll it out, the machines roll it back. Okay, so that was the technical practices, and now let's talk a little bit about some process ideas. So the first process idea, and this is my word, but the idea of making units of software small. So the way I like to think about it is a minimal viable feature. What's the smallest part of the feature that I can build and test and deploy, and then I can make it bigger and better over time. So And the insight here is, as a user, I would much rather have a system that has one really good feature than two not very good features. So every one of us carries around a supercomputer in our pocket. And maybe just think about the last time you updated the operating system on your supercomputer. Did you ever say, wow, I'm so glad that this new version of Android has these 100 features, right? Everybody's laughing, because no, you don't care. You just want like the 2 or 3 features that you care. Battery life, right? Oh, this is the new version of, you know, whatever, the mail app or something like that. Do you know what I mean? Like, you care about a small number of features that you actually use, not, you care about the quality of those features, not the quantity of them, right? So my advice to you, to the extent that you have this control, but certainly to your teams and to your management, is like, build one thing that's really good instead of 2 things that are not so good. And you know, when I say one great thing, I don't mean perfect. You know, a lot of times there's what we call this 80-20 rule, right? You can get 80% of the value with 20% of the effort. You know, that's the minimal viable feature part. So I'm not saying that we should spend a year building something that's absolutely perfect, but something that, you know, minimally meets the need. And then when, not if, when we have a conversation or, you know, about what, you know, we're limited in time, what should we do? I always suggest that rather than reducing the quality of the thing and releasing 2 things, maybe we should just reduce the scope. Again, only release 1 thing, but have it be really good. OK, this is related to a thing that is in the state of DevOps research, which is small units of work. So rather than, you know, so the low performers, with everything measured in months, have a whole team, you know, and they're working, and they release, you know, 1 month worth of the team's work all at once. Boom. And when something goes wrong, where is it? Who knows, right? It's like a whole team times a month. Like, that's a lot of work. Where, you know, if something went wrong, like, where is it in there? That's really hard. If you're able to do it in weeks, okay, that's better. If you're able to do it in days, okay, that's even better. If you're able to do it in hours, that's even better, right? If you're rolling something out that, you know, is one person's work for a day, or, you know, the whole team's work for several hours, and it goes wrong, well, like, how many things could it be? Like, there were only 2 or 3 changes in there. Does it make sense? Like, and so those small incremental changes, there's a reason why small units of work lead to better quality. It's because they're easier to understand, they're certainly easier to test, they're easier to code review, and when something goes wrong, they're easier to roll back and to diagnose what went wrong. By contrast, really large changes are riskier. And actually, the research shows that the size of the risk is not linear in the size of the code change. It's actually nonlinear. It's actually more like geometric, so like it goes with the square or the cube or to the 4th power or something like that. Why? Again, because when there are, you know, let's call it 100 code changes in that month of the teams working, those changes interact with each other, right? As you well know from testing. And so those things are a lot riskier. And so again, every time that we can reduce the size of the code changes, it means that we can roll things out faster, but it means they're actually better quality. And then the other nice thing is when we're producing small units of work and we test things up front, is that the main branch, or whatever we call it, is actually should always be shippable. So it allows us to increase the rate of changes that we're making, but reducing the risk of those changes. So you win on both sides. You get both faster and you get higher quality. OK, I'm sure you are familiar with this idea of feature flags. So this is something that back 20 years ago, it was independently discovered by a bunch of different companies. You know, the idea is, well, if I'm making small units of change, I mean, that's less than a whole feature, right? right? If I'm making an hour's worth of work, like no feature can be done in an hour, right? I don't care how fast you type. So how is it possible for us to deliver something that maybe represents, weeks of work, but deliver it in small units? Well, one technique is this idea of feature flags, where I can continue to make changes to the feature, but it's off for the users, right? So it's on for me, so I can maybe try it out, or maybe I can even run some automated tests. But it's off for everybody else. So I can slowly build it up over time, safely, in production, and not expose it to users that, for something that doesn't work. And again, this idea allows us to build a lot more solid systems. It allows us to decouple the idea of releasing a feature from deploying code. Those are two concepts, different concepts. If there's any issue in production, having this feature flag, it can just turn it off, right? I can turn it on when it's ready to go, I think, but we can also turn it off if it's not working. And then it allows us to rapidly, develop and test and verify these changes in production. Okay, so that's the process. And now lastly, I want to talk a little bit about some culture things. Okay, so the first thing that I want to talk about is empowered teams. So this is something that is very important to the state of DevOps research. That it's shown that if you have empowered teams and these other techniques, that it predicts the better software delivery performance and also the better business performance. So when I say empowered teams, what do I mean? Well, I'm going to contrast it with unempowered teams. So again, I started in software in, let's say, 1988. So so whatever, 34 years, something like that. And we used to have different teams for all these things. Like there was some team that came up with the ideas, and maybe they wrote a big, long, specification document, and they said, here's the specification document. Randy, please, type it. And then there would be a team that I was on. I'm a developer. I would be the development team, and I would furiously type for maybe months. And then we would hand it off to a quality team, and they would, find all the bugs that I didn't find because I didn't have any testing and, whatever. And then finally, we would hand it off to somebody else that would operate the software. Well, now, having teams that are empowered with all the capabilities, like within the level of the team, is much more powerful. So rather than having those separate teams, let's have the team include all the skill sets together, the ideas, the development, the quality, and the operations, and have that team aligned around a particular customer problem or a particular business problem, with clear goals and metrics. And so the organizations now look more like this, where we'll have at eBay, for example, like we have the selling team that builds the software for the people that sell on the site, and then we have the buying team that builds the software for people that want to buy things on eBay, and we have the payments team, and all the way down the different domains in eBay, and each of those teams generates the ideas, does the software development, does the quality, and then does the operations. And so why do we do it this way? It's because those teams are able to move faster independently of each other. They don't wait on the next team and the next team and the next team with these handoffs. Cool. So the other idea is trying to limit work in progress. Limit work in progress. What do I mean by that? Well, so again, traditionally, if I had a team, for example, of 5 people, maybe I would do it this way. We have lots of features that we want to build. So maybe I would ask one person to develop a feature and develop it for months, and then another person to develop the second feature, another person to develop the third feature, et cetera. And this is okay, but notice that no value, nothing happens to customers in this example for 4 months. So that's not as good as we could do. So what if we did something slightly different? What if instead we had the first 2 people work together on feature 1, and the second 2 people work on feature 2, and then the third person can work on feature 3. Well, so now the benefit is that feature 1 and feature 2 happen in half the time, so maybe they only happen in 2 months rather than in 4 months. And customers are, yes, please.
Yeah, you said we can ask. So this progress can be made with senior developers, like seniors only, or what do you think in a way of like juniors?
Oh, thank you for asking. That's a great question. This is one of the best ways to train junior developers, I think. The best, the worst thing to do for a junior developer is to leave him or her alone. Not because they're not competent or they don't good, but like they're still learning. And what's the best way to learn is in combination with somebody else. Again, by the way, these two people could be a developer and a tester. They could, do you see what I'm saying? Like have two people. Not every feature works this way, but a lot of features work like this, where two people collaborating, sharing ideas, they'll actually end up coming up. There's a lot of evidence that, or research that shows that two people working together, they release things in half the time, but also it's 60% higher quality. Again, why? Because if Oliver and I were working together, Oliver would see the mistakes that I was making that I didn't see, and I would maybe say, he doesn't make any mistakes, but like I would see some maybe mistakes that Oliver would make. Does it make sense? Like we would work together and we fill in the gaps in each other. And like I'm so glad you asked that. It's, again, I was junior too, we all were. Junior people have more gaps. They don't know what they don't know. And so by pairing, even two junior people together, by the way, is a good way to do it. Again, because they don't have the same gaps, right? The gaps are offset from each other, right? Yeah, great question, thank you. Cool, so rather than doing 5 features at the same time, let's do a smaller number in this particular example. And then when those, that little pair that's working on feature 1 is done, they can work on feature 4 and so on. Okay, well, but I think we can do even better than this. So what if we, for each of those features, thought ahead and planned just a little bit and said, well, are there smaller units that are not just the whole feature, right? Maybe we use the feature flags or other techniques where we release, we finish a little part of the feature and then we deploy it to production and then we go from there. So this iterative development makes it even better. It allows us to be resilient to this. So I have had this happen a lot, where if I am working really hard on something that is taking me a long time, like 2 months or 4 months, something like that, it can, 4 months is a long time. So maybe the thing that I'm working on is no longer the highest priority for our team or our company. Has anybody had that happen to them? Really? Nobody? Okay, thanks. Yeah, it's happened to me a lot. But if the value of releasing smaller units of work allows us to be more resilient to this. Why? If I've done 3/4 of my work and I haven't released anything and I stop, there's no customer value at all. But if I have released, 1/4, 2/4, 3/4, there is at least some customer value that I've completed. And I can, say, okay, that's done, and maybe we come back and we finish more, or maybe we don't need to. So if we take this iterative development approach, we get a lot of benefits. So the first one is, I didn't highlight this before, but like, if we are working on a smaller set of things and we get them done more quickly, we just work on the highest priority things. In that first example, we were treating the priority 1 feature and the priority 5 feature the same. Does it make sense? Like we were putting the same amount of effort into both of them. Whereas when we shifted to the limiting work in progress, we put more people, more effort on the highest priority stuff together. We also get more value earlier, right? So in that example, we got the value of the feature number 1, and we got the value of the feature number 2 in half the time. Once we move to the iterative development, we're producing subparts of the feature along the way, and again, getting more individual value. And we're learning along the way too, right? So we might learn that the feature is harder than we thought, or we might learn that the feature is easier than we thought, or we might learn that the feature isn't good, that we should try something else. But the only way to learn that is by releasing things. And then finally, again, that idea of changing priorities. If we're delivering value in those, features or sub-features in those smaller units, anytime we can stop when there's a change in priority, and maybe we lose a couple of days of work or a week of work, but we don't lose 3 months of work, something like that. And also we've provided some value along the way. Okay. All right. The last thing I want to say is making sure that we are always paying attention. We always have some part of our brains thinking about how we could be better, ourselves better, but also how could the system of developing software at our company be better, right? So this idea of continuous improvement is super important to, and is one of the critical aspects of these high-performing and elite-performing organizations. They have a learning culture where they spend time, not a huge amount of time, but like a good amount of time thinking about, okay, we just finished that feature. What would have made it easier to do that, right? What can we learn from what we did, and maybe we can do it better? And Gene Kim, who's one of the co-authors of this Accelerate book, but also an author of lots of other books, he has this very provocative statement. And his provocative statement is, improving daily work is even more important than doing the daily work. You're like, what? That doesn't sound right. Like, my whole job is doing daily work. How could it be more important to improve? Well, when we do the daily work and we put in 1 unit of effort, we kind of get 1 unit back. Does it make sense? Like, 1 unit of effort, 1 unit back. 1 unit of effort, 1 unit back. But if we spend, not all of our time, but some of our time improving daily work, maybe we can get 1.5 units when I put one unit of effort, and I maybe get 1.5 units back, or maybe I get 2 units back. And by the way, I don't get 1.5 units back only now. I get 1.5 units back forever if I've improved how I'm working. Or maybe I get 2 units of work back forever. So that effort that we would spend on improving daily work has a compounding effect, just like interest in a bank account, right? Or inflation, right? It has this compounding effect where it continues to give value over time. Okay. And the last thing is, a lot of times in big legacy organizations, and I've worked in them, is there's resistance to this. Like, well, we really shouldn't spend a lot of time on improving stuff. Like, just get your work done, Randy, and please. And one of the things, the techniques that I found is really valuable is just simply asking this question. Hey, can we just try an experiment? What if we try an experiment where we do the work a little bit differently? And let's see if it provides value. And if it's better, then maybe we can do more of it. And if it's not good, okay, I'll tell you, and then maybe we can try something else. But like, this is a very simple way. If you work in an organization, I also do. If you work in an organization that sometimes resists change or resists trying new ideas, this is a very simple and easy way to reduce the stress about it, to reduce people's worry about it. Does it make sense? Let's just try an experiment. And can we try it for a couple of sprints or a month or 2, and then I'll tell you, we can decide whether it's a good thing or not. Okay, let's just try an experiment. Okay, well, so thank you very much. I hope that was useful and fun. We talked about technical practices, we talked about process, we talked about culture. So, köszönöm.
Oh, yeah. It was an excellent talk. I don't know how you're doing. US folks are always great at selling ideas. I bought it. I want to do it immediately. So big thank you for Randy.
Thank you
for being here, and also Emily. It was a pleasure. We are going to rush to a dinner. You have a couple of more minutes to catch them and exchange ideas, so use your time. I'm not going to waste your time, so I'm going to stop now. Come to Randy. He's a great guy. Emily, I know her for some time, so use your time. Thank you for coming. It was a pleasure.
Thank you.